afternoon, and welcome to sunny San Diego. And thank you for joining us at the Custom SQL Table. I really do appreciate each one of you joining us for today's session. And one of the first things I really want to know is how many of you in the audience today have DBA access or developer access in your databases in order to create views in tables? Okay, good. So I see some of you do, some of you don't. So then for those of you who don't, do you need to wait for IT to create these objects for you? You know, wouldn't it be nice if you could just connect these queries you're writing to in Access, Toad, SQL Explorer, maybe some other tools directly into Tableau itself? Well, I'm here to say that we can with our custom SQL options. So this is why you're here. This is what you're going to learn. And again, very excited to have you in the room. So most of you, because this is kind of an advanced course, are already versed in the awesomeness that is Tableau. And we're going to extend some of that awesomeness by teaching you to use custom SQL written visually or line by line to extend your capabilities. So with that, my name is David Spezia, and I work on the Customer Solutions team, implementing and training many world-class organizations, such as yourselves, on the Zen of Tableau. In fact, I've worked with some of you in this room directly, so very honored to see you again. The main topics we're going to be covering today are going to be inner, right, and left joins. We need you to have the fundamentals in order to let you loose. Then we're going to connect the data using custom SQL without the need for IT and without the need for DBA access. Further, we're going to leverage these database functions to extend the capabilities of Tableau itself. So with all of that said, I want to introduce you to Matt Hull.
And good morning to you all. My name is Matt Hull. I'm part of the Professional Services Group. What I'm here to talk to you about today is the SQL fundamentals. This is lesson 1. I will be talking to you about joining tables. Basically, how I'm going to do this is I'm going to show you all the different joins. They're the inner, left, and right joins, and then we're going to go through the exercises in which to solidify the teachings of those joins. So let's get started. I'll just ask for control again.
There we go.
Okay, first off, we have the inner join. Basically what that is we have two tables, table 1 and table 2. We look at what inside of table 1 and table 2 can actually be consolidated together. As in, for instance, we have table 1 with categories 1, 2, and 3. We have table 2 with categories 2, 3, and 4. What we're going to get as a result using the inner join is categories 2 and 3. And down below is an example of that, if everybody can see, a select from inner join table 2 on table 1, column 1, table 2, column 2, or column 1. And what that does is it creates the reference between the two tables. Here's the left join. It's sort of like the inner join, only when we group the two tables together inside of table 1. If there is something that's not inside of table 2 in table 1, that data will still be represented, only there will be nulls instead of what's inside of, instead of it just being omitted. So say, for instance, inside of table 1 is categories 1, 2, and 3. With table 2, there's categories 2, 3, and 4. What the result is going to be is 1, 2, and 3. Only inside of category 1, we're going to have nulls instead of values that would have been represented inside of table 2, inside of result set. And last, we have our right outer join. Now, inside of these two tables, what it's going to do is it's going to take exactly like it did with the left outer join, only table 2 is going to be fully represented. So, again, table 1, categories 1, 2, and 3. Table 2, categories 2, 3, and 4. Categories 2, 3, and 4 are going to be represented, only in this result set, where we would have table 1 data being represented for category 4, we just have a bunch of nulls. So let's go ahead and look inside of Tableau, and we'll set up some examples for that. So here's our first exercise. Now everybody go ahead and open up Tableau Desktop, and we're going to do the same thing. So we're going to connect to the Superstore sales data, and that should be inside of your My Documents under Tableau repository. Inside of Data Source, there should be that Excel document. So does everybody have that? Good. So inside of that, we have the Custom SQL Radio button that you're going to select. And then you're going to select the little button off to the right side. It's the SQL Editor, and it's got the little 3 dots on it. So I'm going to go ahead and do that myself. We're going to open up Tableau Desktop, connect to the data, Microsoft Excel. We're going to go to Documents. My Tableau repository, Data Sources, and then we have the Superstore sales data. Now you should see this. Make sure that when you do select the Custom SQL button, Radio button, you have the Orders table selected. So let's select that. Here's our Custom SQL right here. But we want to be able to edit it and see a bigger version of it, so we're going to select this. So here is our Custom SQL. So let's go back to the presentation. Now you all should have a copy of this yourselves, but if you can see the text, what we have is, let me see here, let me bring this back up to the presentation. We have the select all of our dimensions, and then right above our from statement is this returns field that we're going to want to pull in. So that's the status. Inside of the returns table, we have a status and an order ID. Now the order ID is the primary key, and that is what we're going to be joining the 2 tables on. So we're going to add the status as the field that we want to pull in. And then, as you can see, after the from, which is going to be included inside the Custom SQL, we have the inner join in bold, which will be what you will type in. Inner join, returns, which is the table we want to join to, on, and then we're going to bring the 2 order IDs, which is the primary key, together. Did everybody do that? Great. So we're going to do that ourselves. I'll put that right there. And let's take a look at the results. So as you can see, as part of the status, we have all of the statuses as returned. So we don't see any nulls or anything like that. The reason is because everything that was inside of the table 1, or our orders, that didn't have a result inside of table 2, they were completely omitted. So we have a smaller subset that was returned, but we don't have any nulls inside of our status. And we're going to do the same thing for the left join. As you can see, we have the left join of the returns table. We're going to, for those of you that are following along with your Custom SQL, we're just going to replace inner join with left join. Did everybody do that? Good. Afterwards, let's open up our result set. And our result set is that button at the very bottom left corner that you can just simply select. It'll query the database, or in our instance, the Excel spreadsheet, and bring up our results. Now, as you can see, this one, because it is left join, and our orders, some of them have not been returned, so they're not going to be included inside of our return table. So as you can see, there are a lot of nulls. Now, the null means that they haven't been returned. So that's our left join. Now let's go ahead and do it with our right join. Simply replace the left join with the right join. Everything else is the same. And we're going to take a look at our results. As you can see, everything is all the nulls have disappeared again, but that's only because we're inside of our second table, our returns table, we don't have any order IDs that aren't inside of the orders table. So there aren't going to be any nulls once again, but it's only because the order IDs inside of the returns table are directly going to join up with the order IDs inside of the orders table. Okay, so now I'm going to hand it over to David, and he's going to take you through lessons 2 through 5, and I will be in the back of the room just in case any of y'all have any questions while he is speaking. Now, we do have the exercises that we're going to give out for every single lesson, but if you do have any questions while David is speaking, just be sure to raise your hand, and I will come over and help you with whatever needs you have. All right, David, go ahead.
Thank you, Matt. Now that we have the fundamentals of SQL, we have the understanding of the different join types, I want to walk you through leveraging those fundamentals inside of Tableau to drive further content. But we're going to start kind of basic and work our way up to something a little more advanced. The first thing we're going to do is we want to cover Excel SQL. So Excel does have some lightweight versions of SQL that package with it, called the jet drivers. But we want to look at some specific functions, and most particularly the VLOOKUP function. We want to eliminate use of that function with the functionality that we have in Tableau. So let's talk a little bit more about the common uses of our VLOOKUP function. So this allows us to have SQL-like or SQL-esque joins that return simple results between worksheets in Excel. We can quickly add in information from one Excel sheet to another. So if I had a series of orders and I wanted to pull who the managing director was for that region, if I had that information in my regions table, I could simply do a quick little VLOOKUP regions on my regions table where return type for the managing director, and then get that information in my additional table. Also, I can create dynamic reports with filters. So we can actually have dynamic fields that feed into the VLOOKUP function and return some dynamic results. And from that, we can start building some lightweight dynamic applications. Again, this is all very Excel heavy, may not always be optimal or scalable, but you do have a lot of control. So we want to show you how to replace some of these features with Tableau itself. But first, I'm going to show you the VLOOKUP syntax and how it works in Excel, and then move that lesson into Tableau. So with the VLOOKUP syntax, it's a little complex. We're not saying select star from join on equals. We're saying VLOOKUP lookup value. So we're specifying a specific key we're going to look up in a table array. Well, what's a table array? That could be a named range or just a specific series of columns in a different worksheet with, again, with, very important here, the lookup key on the far left-hand side. Then we specify a column index return number. So within our table array, if we had 3 columns, and we specify 3 here in this syntax, we will get the third column's result returned when the VLOOKUP finds a match. And how does it match? Well, we have a range lookup option. We can have a fuzzy match or an exact match. Very rarely would you ever use the fuzzy match. The exact match is what happens by default. So this is an optional argument. But if you leave in true, it will actually go in there and look for a fuzzy match. It will look for, say, if I type in Danny, it might return on Dan or Daniel. So it's a little fuzzy. There's some black magic there. But basically, we want to use the exact compare most of the time. So let's go ahead and see the VLOOKUP in action. What we're going to do is we're going to join orders to regions in order to get the managing director pulled out. So I'm going to go ahead and go to my desktop here, and I'm going to open the Tableau Customer Conference Superstore Sales Set. This is a special data set I created for you for this specific lesson. And we've got orders, returns, users, regions, zip codes even, holidays, and test dates. So we've got more than what's in the normal Superstore sales. And think of each one of these tabs as a table. So what we want to do for orders is we said we wanted to VLOOKUP region. So we look up regions here. And in the region table itself, it's rather small. We just have the region, the manager, the VP, and the office. But back in the orders table, we don't have that manager. We simply have region. So if I scroll over to where region is and I insert a column, I'm going to go ahead and call this manager. And I'm going to type in equals the lookup. So again, VLOOKUP function, and it's going to guide me through the syntax here. Lookup value. We said that was our key. So my key here is central, comma, table array. We specified that we wanted it to be the regions area, and we care about these 5 columns, or these 4 columns. So I'm going to go ahead and do comma, column index number. We said we cared about manager. So column 1, 2, that's 2, and comma false. You don't have to type this in. Again, it's optional, but I will type false to get that exact match. And now we can see Chris has been returned for the central region. And if I were to pull this down for the rest of these, you're going to see I get the appropriate sales manager for each one of my orders. But we don't have to go through all this kludgy Excel syntax. In Tableau itself, we can actually replicate this. So I'm going to go resume my slideshow here. And before we get into actually doing it on our own in Tableau, I want to talk about the drawbacks of the VLOOKUP function. It's complex in syntax. You have to really understand what's going on and how to form it. And it's really slow with large data sets over about 10,000 rows. Again, it's a single parameter on the where clause. So as we're doing the lookup, we're only specifying a join on one field. It's limited also to a single return value. If there was multiple records for the East region in my regions table, I would get the first matching record returned, and it would ignore the rest. There's no aggregation, again, because it hits the first record, goes up, I found my match, I'm done. So if we wanted to do those types of advanced lookup features, we would actually have to use something called a sum products function. And if any of you in this room has used that function, raise your hand. Yeah, I didn't think so. I've only used it rarely in my career here. So again, let's make it easy. Let's make it simple. Let's go ahead and use custom SQL in Tableau. We're going to join orders to regions to get that additional information. We're going to talk about the use of the multi-table builder versus the text editor, and we're going to determine total sales by manager actually quite quickly. So I'm going to go ahead and open up Tableau Desktop, and I'm going to connect to data. I'm going to hit cancel here, this is Matt's work. And we're going to connect to Microsoft Excel. And I'm going to choose on my desktop that Superstore sales for TCC. I'm going to hit open. And when I hit open here, you will see I have single table, multiple table, and custom SQL. And it's very important to specify the table I'm going to be using in multiple tables before I get there. If I were have to selected holidays and went there, it's going to start with holidays as my primary table. I'm going to start with orders as my primary table and move to multiple tables. Now I'm going to add a table. And I know I said I wanted to select regions. And right now, if I hit OK, I would be OK with the join it gave me. But I'm going to go to the next tab and specify the join type I want. I'm taking orders.region equal to regions.region. It's already in here. I don't need to add it. But you can see this is an inner join. See, join type inner. So if I hit OK here, and I actually preview the results, when I get to the result preview, I will actually, at the end of this, I will see region, 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 and I will get to the end of this, and I will actually see region manager, etc. But what I want to do, furthermore, is I've created these joins. I can actually go into custom SQL, into the builder, and if I wanted to, I could further do aggregations or other operators in this custom SQL. It's already kind of built it for me with the wizard. But we're going to go ahead and connect to this. And as I connect to the custom SQL and connect live, you notice it creates one set of dimensions and measures for me based off the 2 different tables. Now I can simply drag sales out to the row shelf. I can take manager. Now that's in my data set. Drag that to the column shelf. And I can see the highest grossing manager here is Chris. And actually sort that and revisualize that on the swap. And now Chris actually stands out even more. And I can push him to the top. Again, same lesson. Chris is the #1 manager here. He will have the fattest check come bonus time. All right. Now we're going to have you do this now. We're going to have a more complex lesson here. So I want you to connect to your Tableau desktop, and we're going to do pretty much the same thing. What I want you to do is create a custom SQL, either via the multi-table wizard or the custom SQL itself, that joins orders to zip codes. And then I want you to determine the top 50 MSA locations by sales And for extra credit for you wizards there, let's make a map of those top 50 cities by sales. Okay, I'm going to go ahead now and show you how you're supposed to do that. I am going to open Tableau Desktop, and we're going to go Data, Connect to Data, and Microsoft Excel. We're going to choose that TCC Superstore Sales, hit Open. We're going to select Orders first. Remember, it's important we select Orders first. I know I saw some of you in the audience there. You missed that one. It's going to happen. Even happens to me some days too. So multiple tables, and I'm going to add a table, and I'm going to specify zip codes. And if I were to hit OK here, this is actually where it kind of breaks down, because we don't have the exact same field names in both data sets. We have zip space codes, and we have zip code one word. So we need to specify that join type. And again, it's going to be an inner join. We want things that only match. So right now it's selected city to city, but I can't guarantee you those cities are all the same. So I'm actually going to delete that join. That's the one we tried to do intelligently. Now we're going to really specify what we want. We're going to take the zip space code from orders and then zip code, one word, and add that. And we see here it has the equal sign implying the inner join, and hit OK. And now I've got a unified set of tables that I can go ahead and build information off of. Hit OK, connect live. And what was the first thing we wanted you to do? OK. We want you to determine the top 50 MSA locations by sales. So we can see here, this looks a little different. I've actually got a twisty for each one of my tables and all of the dimensions that are represented for each one of those tables. This is just a de facto of the multi-table interface. If I were to have used custom SQL, it would treat it more like one view, and dimensions and measures would actually be blended. So what I'm going to do here is start a new page. And we said we cared about sales, again, dragging sales to rows. And we cared about those sales by that MSA location. So I got this MSA location, drag that on column shelf. And oof, that's kind of hard to read. I'm a big fan of the bar charts going horizontally. I can go ahead and sort this really easily. And we said we cared about the top 50. Right now I've got, 1,488 different MSA locations. What I'm going to do is take the MSA location pill, and I'm going to filter it for the top by field 50 sum of sales, apply, and now I'm going to hit OK. Now you'll see we went from 1,488 different MSAs down to 50, which is a little more manageable. So the extra credit question here was, let's make a map of the top 50 cities by sales. If we were to try to graph this MSA location, it actually is not a geographical specificity, so it's not going to graph. We need to specify a geographic location that plays a little nicer. So I'm going to duplicate this sheet, and instead of MSA location, I'm actually going to drag out city from my dimensions here. I'm going to take it from my zip codes, though. Nope, it's not there. Yep, zip code city. I'm going to put that over top of, notice how my pill turns blue, the MSA location. So I'm seeing my top 50 cities. Make sure I get top 50 filter. Again, condition top by field 50 sales. Hit apply. Hit OK. And now when I sort this, I got my top 50, but I've got a bar chart still. I want a map. I'm going to go ahead and take show me and specify this area map here. And I'm going to go ahead and blow up the bubble. And now I see my top 50 sales by city on a map as well. OK, that's enough of lesson 1. Go ahead and minimize that and get back. Or lesson 2, we'll go ahead and get back to the additional lessons here. OK. Lesson 3. All right, now we're moving on to a little more advanced stuff. This would actually require you to have some stuff pre-set up in a database other than just Microsoft Excel. Thankfully, we have actually taken the time to install SQL Server 2008 R2 onto each one of these machines. And we've installed some scalar value functions, table value functions, additional data sets that you're going to need to play with this. We're going to play with the concepts, and then we're going to bring it all together with a workdays function that I think you can start to get excited about and see some of the extended possibilities we have when connecting to, in this case, SQL Server, but really any relational database management system that supports these types of functions, like Oracle, etc., you can connect to. But being SQL experts, we're sticking with what we know. OK, so we're going to use Tableau to call functions that were custom written in our database. And this gets kind of neat. But before we get there, I'm going to want to set a fundamental of what Tableau is. Tableau is a visual pass-through engine. to your data sources. So we have data in our data warehouses, in our data marts, in our files, and in our cubes. And our interface makes these beautiful visualizations, but it makes that off of SQL that has been taken from the user interface, visually interpreted with our VizQL engine, and then passed through a series of connectors into the data sources and ran at the data source location. So what does that mean? That means my visual cues in Tableau actually generate paragraphs of SQL code that is sent to the database. The database then executes that SQL code and returns result sets. We're not actually like hyper interacting with the database and returning rows and records and stuff. We're returning result sets from queries that were ran. So if we can control what is in that query that's sent to the database, we can actually call items that exist only in the database that Tableau can't even see yet. So things like scalar value functions. And furthermore, we can actually take data from our SQL connector or our relational connector and push data into extracts for our fast data engine. That's actually a subject I will be teaching later this week. If you would like to attend that, I'd love to have you. It's going to be a similar style. I hope, it's a little techy. I hope you learn. So I'm just shamelessly plugging myself to keep attendance high at these things. So moving forward to scalar value functions. This is a function type that is supported by most relational databases. And what makes it a scalar value is it returns a single data type. It just returns one value for one data type. And these scalar value functions can have multiple inputs. That means I can send in a region, a manager, a time frame into this function and then have relevant results to those three input parameters returned via the function. These things with that nature can be leveraged to be highly dynamic. However, in SQL Server, one thing a scalar value function cannot do is call a stored procedure, which can get really crazy inside the database if you want, you connect to different web queries, all kinds of stuff once you get information in a stored procedure. Unfortunately, we didn't quite connect to them because they're just too dynamic. They cannot be locked down. So pass-through functions, they're handled with raw SQL. So I said things were too dynamic to connect to. Well, Tableau has a metadata layer where different data types of the columns are specified. So we need to know the data type of the column in order to know how to best visualize it. There are all kinds of algorithms written into the tool to make it easy for you to visualize data based on the data type that you have. So we need to know the data type. So when you look at the raw SQL functions when creating a calculated field in Tableau, you will see they just repeat themselves over and over again because they have a return type. And big important thing here, the return type you select from the functions in the Tableau window must match the return type in the database itself. Very important. If not, it will throw a syntax error for you. It will happen when you start playing with these. Okay. And we also saw back here, there were raw SQL egg and then raw SQL functions. You're almost solely going to use the raw SQL ag function, which means aggregate. We're always working with large data sets, getting back smaller result sets that are aggregated, that are summed along dimensions. We take the measures and do averages, additional calculations. We're almost always in Tableau working at that aggregated level. So just make it a habit to use these. If you do not use an ag, you use the regular function, it will execute at the row level. What do I mean by that? Well, if our aggregate function, or the function we're calling, summed up all the records for a state, and we had 10 records for the state of Michigan in our data set, when we used the regular function and we summed it, we would actually sum Michigan, the sum of Michigan times 10 times. So we're just going to balloon the data out. And when I connect to it, I'll show you the difference so you can get that fundamental understanding of execute at the row level and add up, or actually execute it down the dimension and get the data we're actually looking for. Okay, pass-through syntax. This is very important, and it's a little bit hokey. So raw SQL, and then the word ag or not the word ag, underscore return type. Again, that return type is driven by the return type of the scalar value function in your databases. And we have to call it like we would if we were creating an inline view. Again, We have SQL that's represented, that's created, that's sent down to the database to execute. So the raw SQL I have control over will execute on the database side, so I need to refer to it like I was referring to the syntax in a database. So dbo.name of function, %1, comma, %n. Again, these will scale out as we have, region, product container, date of sale, like additional multi-value inputs. And then we have argument 1 to argument n. Again, that would represent regions, etc., like we talked about earlier. So let's talk about each one of these pieces in depth. Ag, that will aggregate and did not execute at the row level. That's mostly what you want. So you're almost always going to use these ags. Again, I'll show you. It'll make a little more sense here in a quick second. Return type. The most important lesson for return type must be specified and must match what's in the scalar value function. The %1 and %n are aliases that will be replaced by the contents of the arguments. So if we look at arg1, argn, these are fields, constants, or parameters in Tableau. All of those things can take the place of the placeholder and then execute in the custom SQL. So now that we're getting through all of this fundamental stuff, let's get our hands dirty. Let's start exploring some of this. All right, so what I want to do now is I want to explore my scalar value functions in the server. We're going to create a raw SQL aggregate function that returns regional sales. I'm going to show you the difference between ag and non-ag, and we're going to return the sum of sales for a region in a crosstab, along with other dimensions. So let's go ahead and open up our SQL server. And if you wanted to follow along here, you actually can, because this SQL server is installed on each one of your machines. I'm going to go Start, SQL Server Management Studio. I'm going to go ahead and connect. And I'm going to go into my databases, and I'm going to go ahead into my test dynamic database and actually look at the tables here. You can see I've got orders, regions, holidays, etc. The same matching what was in my Excel. I've also got programmability functions, scalar valued functions. So it's a bit of a funky drill down path. But this is where I had pre-created some scalar value functions for you to connect to. It's very simple stuff that we've created here. We can see that this function takes in a region, a string region up to 10 characters, and returns an integer. So this is important. This right here, this return type of integer, this is how I know in Tableau that I want to use the INT return type. And this is all it's going to do is select the sum of sales from my orders table where my region equals the region of input. So let's go ahead and connect to that in Tableau. I'm going to go ahead and open up Tableau Desktop. That's already open here. I'm going to go in a new sheet. I'm going to go Data, Connect to Data. And I'm going to choose a SQL server this time, not that Excel stuff. And I'm connecting to my local host. All of you can connect to your local host. Hit Connect. And now I'm going to select Test Dynamic here. And I'm going to select the orders table itself. We're going to extend functionality onto the orders table. I'm going to go ahead and hit OK and connect live to that information. And we said we cared about sales by region. And I'm going to look at this as a crosstab and break it down a little bit further and throw product category in here as well. So I've got an interesting crosstab, but if I also want an additional field on the right-hand side that shows me the sum of all sales for that region, I could do that in custom SQL, or I can do that in a table function. Well, we're going to do that in custom SQL because that's the type of class we got going on today. So I'm going to connect to that custom SQL, that scalar value function we have, by creating a calculated field. And we're going to get this as going to be our regional sales. And in my regional sales, we're going to use our pass-through functions. Again, in the functions drop-down, I can go to pass-through. And we said we wanted raw SQL ag _int because that's the return type of our SVF function. So I want to select that. And this syntax takes a little bit of practice. And I'm going to call DBO, or database owner, dot, bracket, scalar value function. That's just my own kind of naming convention, _ region sales. That's what we called it. And close bracket. And then I'm going to put my placeholder in there, my %1. If I had multiples, I'd do comma, %2, comma, %3, etc. And then I'm going to do comma after the quote. And this is what I'm going to pass in. I said I can pass in a dimension. So I'm going to pass in region, actually. So my region, pass that in. And it's going to tell me here that the syntax is OK. I'm going to hit OK. And now when I drag this onto Tableau, it's actually going to fire off the scalar value function. and go ahead and sum for each one of these pieces that entire sales for that region represented over and over again. And that's what the ag version of it does, is it looks at the entire region. If I'm going to change this now, I'm going to change this to execute at the row level. There's 8,400 rows in this table. I'm actually going to take the value for central, this 5 million, and represent it 2,000 times and then add it up. It's going to be wrong. So let's show you that it's wrong. And it's actually going to be kind of slow. So I'm going to go ahead in here. Now I'm going to change my regional sales. I'm going to edit this. And we're going to remove that ag. But I'm going to actually do that with a copy of the function. I don't really want to break it. I'm going to go ahead and duplicate this. And I'm going to go ahead in here and edit. And all I'm going to do is remove the AGG. It's still going to say it's valid. It is. It's valid syntax. This is not a valid use case, but it's valid syntax. I'm going to take region sales copy, put it over the top of the ag function that was there. You see it says sum, because again, this is executing at the row level in my database, and then I'm adding up 5 million 2,000 times. And look at this, it tells me an error occurred. Can't even handle it. Show details, heuristic overflow. So I couldn't even return the value to the screen because it couldn't even handle the overflow. It went over 2.4 billion. So that's how you know you don't want to use that. You want to have that ag. So if I were to cut down the granularity a little bit here, if I took in, say product subcategory instead of product category, it might actually fire and not overflow on me. We'll see it turn in here. So let's go ahead and hold our fingers. Maybe it'll work. If not, no big deal. We're not going to use it that way. That's using it in the wrong method. So I'm glad it broke. So now it's firing off all those, and it's going to add the individual row levels together for me. It's not going to take close to 30 or 40 seconds here on this laptop. So not only is it wrong, it's also inefficient. And we can see it actually executed. And there's, probably 60 or so records here that are represented in appliances, but it took 5 million and added it up a whole bunch of times. So actually probably like 120. So it's wrong. So that's what happens when you do ag versus not ag. So we're going to go ahead and get rid of that. You know, want anything to do with that. We want this one, regional sales. Much quicker, much better user experience. Okay, now that we've seen that, and we've seen it mess up a little bit because of just a wrong use case, we're going to hand this over to you. We're going to get your hands on the table for lesson 3. We're going to have you create a raw SQL function that connects to this new capes table function called SDF underscore prod cat sales. So we're looking at sales by a product category. I want you to create a crosstab for the East region by product category and product subcategory that has both the sales for that product category subcategory join and the total product category for the sales. And extra credit would be to add in total region sales for the East. So to repeat what I just did, let's go ahead and do that now that we've seen the lesson through. I'm going to go ahead and go into Tableau Desktop, and I'm going to connect to data. Already connected there to table order, so I don't need to go through that whole rigmarole. And we said we cared about a product tab by East region, by product category, and subcategory. So let's go ahead and do that. Well, we got product subcategory already out here, but we cared about product category, and we cared about the East region only, so I could filter this, say East region only, hit apply, hit OK. So we're getting there. And we've already got the extra credit done because, well, we did that earlier. Now let's go ahead and do the actual assignment. Right-click, create calculated field. And I right-clicked in the measures space. That's where we call that from. And this is going to be our prod cat sales. And I'm going to connect to my raw SQL ag function. So pass through raw SQL ag integer return type. And we're going to do the syntax now. Again, it's a little wonky. I'm going to do DBO dot, the bracket, scalar value function, underscore. And if I were to spell it wrong, it would actually fail. So you got to be careful here. Prod cat sales, close it, open my parenthetical, and put in %1, and close it, and close the actual string here, comma, and I want to do product category. So put product category in here, and we'll see the calculation is valid. Hit OK. I now can take this prod cat sales, dump this on the measure values, and now we'll actually see the total sum of sales for that product category. All right. Let's go ahead and move on to the next lesson. Go back to my slideshow here, and we're going to move on to custom SQL and the TVF, or the table value function. We can actually call custom SQL to create a dynamic table of values based on some input. This is still kind of in infancy in Tableau. We're not totally dynamic with it yet, but we can pass in some string values and get an interesting table value back. And coming up in 8.0, which some of you have probably already seen, we'll actually be able to pass some parameters and other things in here, making this far more dynamic in version 8. So another good reason to switch over to 8. Table value functions return a data table as a result set. Not a single value, not a single point, but an actual table of results based on an input. And they can have multiple inputs. So again, I can specify a region, a category, a subcategory, a date time frame, and have that kind of where clause down or trimmed down to what I want relevantly. And again, this can be leveraged to be dynamic. I could also pass in a username with that, and I could get all the records for a single user back. Again, here's a very important syntactual piece for SQL Server. A table value function cannot call a stored procedure because stored procedures can alter the substructure of the database, and we're a reporting application. We need to have a rather static concept of what we're connecting to. So calling table value functions in Tableau. So TVFs, again, can be called only from the custom SQL editor. You can't call them from the multi-table selector. You can't call them right from the SQL chooser itself. You actually have to handwrite in what you want to call. TVFs cannot, very important, cannot accept Tableau parameters, fields, or consonants, only hard-coded values. Today, moving in version 8, we'll be able to dynamically pass in some additional pieces of information. So how does this even matter? How does it scales? If you have to create the same workbook for 2,000 different concepts and you don't want to do the different filters, you can actually scale out workbooks to connect to these table value functions. And then people who aren't really allowed to see stuff for only their store can only see stuff for their store as opposed to other stores. So you can actually put this out there to your analytical community. So let's go ahead and show you how we use TVFs in Tableau. I'm going to show you a TVF in my SQL Server. I'm going to create a data connection to this DBO table value function region for the East region, and we're going to go ahead and create a quick visual off of that. So again, we'll go ahead and do this quickly. Go down to Tableau here, and I'm going to go Data, Connect to Data. And we know we want to connect to a SQL Server, and it's our local host. I'm going to connect, and I know that I need to connect to this test dynamic database, and I'm going to choose Custom SQL. And I'm going to hit the builder. I'm going to pretty much get rid of everything here. This is all useless for me. I'm going to do select star from, and this is where I do my syntax of DBO, and dot table value function underscore. Again, this is my naming convention. I recommend it. Region. And I'm going to open a parenthetical and single quote in the word East, single quote, close it, parenthetical, close it. So select star from this table value function. Hit OK. Now I hit OK and connect live, and it treats it just like any other table. This looks very similar to the orders table. Here it is. And I can just go ahead and create a new view, and I can pull out region. And you'll notice that I'm only going to get the East region. It's been truncated to only the East region. That table result that's returned by that function only has the East region in it. I can put sales on here, and again, you'll see it's only by the East region. I can see what products I had, but only for the East region. Okay, now let's go ahead and get your hands dirty on that one. And what we're going to want to do is we're going to have you create a connection to a different table value function called region PC. The PC stands for product container. And I want you to connect for region and small box. Those are the region and product category for you, or product container. And I want you to create a visual from that data set. And the extra credit here is going to be a little tricky. I want you to return all rows for all regions for the product container type of wrap bags. Okay, now that you've tried that, let's go ahead and show you how it's done. I'm going to go ahead and open up Tableau Desktop here. And I'm going to go ahead and, again, do File, Connect to Data. But I'm going to reuse what we created a little earlier. I'm going to go ahead and edit this connection. So just for the sake of time here, and I said region and PC, and my first argument is region. My second argument is small box. I'm going to hit OK. And now I'm going to go ahead and pull region out there. And we've got East. I can pull sales out here, and I'll see my sales just for the small boxes in the East. I can prove that out by taking product container, looking out here. All we get is small box return. So the second piece, did any of you figure out how to return just for wrap bag? Okay, well that was a trick question. You can't actually do that. If I were to come in here and edit this connection, and actually instead of just trying to do like all or something, I can't really do anything. I pass in a star here, and I think we said we wanted it to be for wrap bag. It's actually going to break. So wrap and bag, and we're going to see something happen here where we get no data returned because we can't actually specify a star to do all regions, etc. We'd actually have to build into the SQL function on the SQL side a special case handler for that. So that was a bit of a trick question, but it's something you're probably going to want to do. So you may want to investigate doing that in your custom SQL itself. Okay, moving on to the last lesson. Something I'm pretty sure some of you are actually excited to see is we're going to put this all together, custom SQL, Tableau, and we're going to call a workdays function from Tableau. We're actually going to feed in start date and end date and get the number of working days in between the two, or in this case, we're actually going to get the embargo days, so the days we're just not going to process data. We're going to get the holidays, or we're going to get the weekends between any two dates. These really are best for aging or queuing, so maybe like I have loans coming in, and I have 5 days to kick loans out of my queue, but I know I'm not going to process on Thanksgiving. Well, I don't want to be held liable for Thanksgiving if I'm not going to process. So my reports shouldn't count that as a day for aging. This can be difficult to accomplish in Tableau, I'll be honest. It's really hard to do without dynamic record looping. If I can't say, give me a start date and end date and go off and do additional math, come back and give me a result, it's kind of hard. But what we can do is we can take a list of holidays, put those in SQL Server, and then build a scalar value function in SQL that looks at the difference between those two dates. So hands-on the table for lesson 5 here. I'm actually going to have you create 3 raw SQL AG functions, again, AG, for returning the number of embargo, weekend, and holidays. I'm going to have you create a crosstab using all 3 of these functions showing the number of occurrences between the date start and date end for this specific table, table test underscore dates. And extra credit, create a function that leverages these existing 3 to give me the number of days worked between start and end. But before we cut you loose, I'm going to show you in the data server itself, or the database server, the actual function, so you get a little more of a handle for it. So we have the scalar value function test holiday, and we can see it takes 3 inputs. It actually takes 3 inputs: a date start, a date end, and a type. And the 3 different types we have in our table of dates are weekends, embargoes, and holidays. So we're just not going to process some days because we're not going to process, or we're not going to process some days because they're actual calendar holidays. So we're able to handle multiple different types of we're not going to work today right in here. And I can actually show you the data itself, look at the holidays. You can see, you know, the IDs, the weekend, the reason code, the date, etc. So now we're going to actually go ahead in Tableau, and I'm going to show you how to do this lesson. Okay, and opening up Tableau Desktop. Again, it's the same thing. I'm going to go ahead and go Data, Connect to Data, Connect to SQL Server. Again, it's my local host. And I'm going to go into my test dynamic database, and I'm going to connect to table test data dates. That's what we said we wanted to go for. I'm going to connect live. And if I go ahead and start pulling information out here on a new tab, I can go ahead and pull out date end and date start. Right now, it's doing the aggregation thing by default. Actually pull the drop down here, go exact date, convert that from a continuous to a discrete concept. Same thing here on date start. Change this to exact date and go ahead and make this discrete. So I'm getting that data table of information. And I want to create our 3 different functions. And again, it's multiple input types. So I'm going to go ahead and create those quickly here. Create calculated field. I'm going to call this number of embargo. And I'm going to be able to duplicate this to make the function building actually faster. And we wanted to pass through raw SQL integer ag, and it's going to be a 3-part thing here. So I'm going to connect to DBO dot scalar value function up. Forgot the name, but we can go check that very quickly. Come in here, it is scalar value function underscore test holiday. Bit of a long name. Come back over here, scalar value function underscore test holiday. And it's going to have 3 inputs: start date, end date, type. So %1, comma, %2, comma, %3, and that's the whole shebang for that. But now we need to give our arguments that replace those placeholders. So comma, the first thing we said was date start, comma, date end, comma, and then our type was embargo. So I can actually have a constant in here. It doesn't necessarily have to be a dynamic replaceable structure. So embargo, and hit OK. So now I can actually, number of embargo, I can rename that because I named it wrong. So number of embargo, OK. Drag that out here and show details. Uh-oh, we had an error. The name is ambiguous. Uh-oh. Let's go ahead and edit that, make sure we specify the right thing. Oh, we forgot our underscore. So it's a good thing. Remember, it has to be named correctly. So even I screw up from time to time. Hit apply, hit OK. Now you see the function fires off, no problem. So these are the number of embargo days. And we said we wanted holiday and weekends as well. Let's go ahead and quickly create these by duplicating and duplicating. I'm going to go ahead and edit this function and call this number of weekend. And all we're going to change here is this to weekend. And hit apply, hit OK, and same thing down here. I'm just going to edit this, and this will be number of holiday. And I'll change this constant here to the word holiday. Make sure I spell it right. Hit apply, hit OK, and I'll go ahead and drag these out here. Number of holiday, number of embargo. So we can see the different numbers of days that pull out here: embargo, holiday, and weekend. So I can see between these date starts and date ends the number of embargo, holidays, and weekend days. Well, that's not telling me a lot yet. What about the number of days I worked? Well, let's add all this stuff together. So we're going to create one more calculated field. And this was our extra credit, and we're going to call this work days. So this one probably would have took you a little longer to figure out. We didn't go over date functions very much, but right here we have the date diff function, and that's what I want to use first. So I want to get the total number of days between these two dates. So I want to know the days between my date start and my date end. And after I get that total number of days, I want to subtract the total of embargoes plus holidays plus weekend days. Hit OK. Uh-oh. Running into a bit of an issue. Let's see, date diff day, date start, date end, minus the number of embargo, number of holiday, number of weekend. So we're probably going to want to wrap that in a sum function, and it contains errors. Okay, lovely. Well, it's not going to fire for us today because this ain't working. Let's see if that works. Okay, so let's get the work days. This is the number of actual days in the month. Fire that out there. This is working appropriately. So ag. So let's go ahead and try to combine all these in a different function. Create calculated field, call this work days, and we'll just simply say work days minus this right here, the sum of embargo plus holiday plus weekend. And it's going to say can't mix ag or ag. So we'll have to work on that. So we got the number of work days. We just can't subtract these things right now. We'll have to work on the syntax and get back to you later on that. Over here, resume our slideshow. So we were able to calculate the number of holidays, et cetera, in between everything. Now I want to do a quick conclusion and some Q&A for you. So let's talk about the different use cases we had. We had totals, so I want to take a dimension, go off, get a total. Some dynamic SQL, feed in multiple parameters to get different things back. We had the workday holidays thing. Any other use cases from the audience? Okay. Any questions and answers that you may have? Okay. And I'll leave you with one quote here. Most of you as analytic workers understand this. We are not dumb. We just have command of thoroughly useless information. So let's take Tableau and make some useful information. Thank you very much.
Thank you.